Hello, my name is Cameron and I represent Rank Projectiles Incorporated. We design model and life-size cannons.
The latest model, the Rank X1 prototype, is designed specifically for launching a circus clown. We'll now demonstrate the procedure for launching the Rank X1. Phase 1 is the preparation phase. In this phase, 1 milliliter of methanol is measured using a syringe beforehand. Phase 2 is the pre-ignition phase, in which the cannon will be thoroughly heated using a blow dryer for 1 minute. Methanol requires an environment with a high temperature to combust in a large extent. Immediately after heating the tube, pour the methanol straight down into the tube. After inserting the methanol into the cannon, close all holes and shake vigorously in a circular motion. This causes the methanol to vaporize, turning it into a gas which causes a greater release of energy. After shaking for 30 seconds, quickly place the cannon onto the stand and place the ball 1/4 of the way inside. Phase 4, Fire Awareness Phase. After the cannon has combusted, quickly take the cannon and shake it to air it out and extinguish the flame inside. Cannon characteristics. Rank X1 has a velocity of 12.8 meters per second. This is found by taking measurements of time and displacement, and then using the kinematics equations, we find the initial velocity of the cart going back. From the concept of momentum, we take both the masses of the ball and cart and determine the initial velocity of the projectile going forward.
Using the standard deviation equation, we have found that our cannon range has a 95% probability to fire between 12.22 meters per second and 13.32 meters per second. Then we determine the average velocity by taking all three trials and dividing by the number of velocities we calculated previously, which gave us an average velocity of 12.84 meters per second. For our horizontal displacement, we have found that on average, the ball will travel 16.87 meters horizontally when fired at a 45-degree angle. To launch an 80 kg clown out of our cannon at a velocity of 12.84 meters per second, the required fuel is 1.358 liters of methanol. This is scaled by taking the required methanol to launch a 1 kg projectile and multiplying it by 80. To scale up our cannon schematics, we take measurements of our model cannon. Since our ball in our cannon is a snug fit, we decided to make the diameter of our life-size cannon 0.65 meters. This is well over the overarm span of the clown. To scale our model cannon to a life-size cannon, we took the ratio between the average length of a person and the diameter of our tennis ball. Then by taking that ratio and multiplying by our model cannon length, we found our life-size cannon to be 7.26 meters in length. Sources of error. Some sources of error are that the tape that was used to attach the cannon to the cart was not a stable attachment, thus allowing the cannon to slightly wobble when it was fired. This affects the force that's responsible for moving the cart backwards, because some of the force moves in different directions, reducing the magnitude of the force acting on the cart. This affects the data required for calculating the velocity and displacement of the projectile. One way to improve this is to permanently attach the cannon to the cart using nails or screws. Moreover, the cart was not designed specifically for a model cannon due to lack of equipment. Using a proper cart, our measurements could have been more accurate and would have affected the results greatly. Also, when shaking the cannon to vaporize the methanol, the holes were not completely covered since bare hands were used to cover them. One way to improve this would be to use corks and lids. This way, we could reduce the amount of heat that escapes the cannon. Another source of error is that our model cannon was designed using cardboard cans and tape. If we were to use one long tin can with the same diameter of our cannon, it would not wear out as quickly as our current model and would be more reliable and consistent.
Combustion is a chemical reaction that occurs between a fuel and an oxidizing agent that produces energy, usually in the form of heat and light.
One action-reaction pair is the cart moving backwards while friction acting forward slows the cart down. Another action-reaction pair is the energy from the combustion of methanol pushing the ball forward, which causes the ball to push the cannon and cart backward. This is the pair that is responsible for accelerating the ball. People often think that rockets lift off the ground because of the push of the exploding fuel against the ground. This is incorrect. Rockets lift off the ground because Newton's third law states that for every force there is an equal and opposite force. When the rocket is launched, the force of the combusting fuel is pointing downwards. This means that there is an equal and opposite force upward, and that is the force that causes the rocket to lift off the ground. By increasing the cannon length, it increases the time the explosion has on the ball. By having greater pressure over a longer time period, the impulse is measured in force multiplied by the change in time. Having the ball in the cannon for a longer time period allows the pressurized force to increase its impulse, which in turn increases muzzle velocity, allowing the ball to travel faster. The downside to increasing the muzzle length is planning to ensure that the barrel length is not so long that the friction causes a greater effect than the impulse.